Okay, we're going to use some real example to show how to do hypothesis testing. Okay, so this session is testing a claim about a population proportion. What is the symbol for population proportion? P, right? And do you remember what is the symbol we use for sample proportion? P hat. Okay, very good. Now we are going to do this. The objective for this video is we're going to learn how to conduct a formal hypothesis testing of a claim about a population proportion P. Now there are a couple of requirements here I want to mention. There are three. So the requirements 1, the sample observation are a simple random sample. So that's number 1. Number 2, the conditions for a binomial distribution are satisfied. Binomial. Do you remember what is a binomial? There are 4 requirements for binomial distribution. And number 1, there's a fixed number of trials. We usually use n. And also each trials are independent. Right? And then the third one, there are only 2 possible outcomes. Either success or failure, yes or no, 1 or 0, whatever. It just has just the 2 categories of the outcomes. And the last one, the probability stays the same for each trial. Okay, so that's a binomial. And then the third one, we have NP greater than or equal to 5 and NQ greater than or equal to 5. Okay, when this happens, when all those 3 requirements are met, then we're going to use a mu equals n times p, and the standard deviation will be n times p times q, right? Okay, and then do you remember when we when we do the confidence interval in the early chapter, then we use z, right? And in this session, our test statistic, which is a z, the formula is this: p hat. P hat is the sample proportion minus p divided by the square root of pq over n. See, the p hat, which is your sample proportion, you subtract what the null hypothesis says about the population proportion, divided by the standard deviation, you get the test statistic. And then you can go ahead and compare that with your critical value or find the p-value. All right, now let's do we keep this in mind, and then we're going to do one example. Example 1. Okay. 926 internet users were asked if they utilize 2-factor authentication, and 52% of them, so this sample size is 926, and 482 of them, or the p hat, is actually 52%. Now sometimes the p hat is given, sometimes this p hat, this percentage is not given, but they give you 482 out of this 926 says yes, they respond with yes. So you can calculate the p hat by yourself. Okay, so either given or you can do the calculate. And I ask you to use this result to test the claim. Now listen carefully. What's the claim? That most internet users utilize 2-factor authentication to protect their online data. So most of the users use 2-factor authentication, which means most means greater than 0.5. So the claim, step 1, right? Did you find the claim? The claim said P is greater than 0.5. See, you identify the claim, you translate the claim into a math notation, and then are you going to put that in HO or HA? Well, we're going to put that into HA, right? Because HO has to be equal. All right, now let's just quickly go over this. Is it a simple random sample? Yeah, we assume that is. Binomial? Yes, either people say yes or no, right? Whether you're going to use the two-factor authentication or not. And then so there are 926 trials, and each one's answer is independent, and there are only two possible outcomes, yes and no, and the probability should stay the same. And NP, NQ, and so N times P is 0.5. Remember here is P, Q, not hat, okay? So NP, NQ, that's just this guy times 0.5, so it's greater than 5 for sure. Then I didn't really do the requirement testing. And in most of the case, when I give you the quiz or something, you don't really need to worry about that. Okay, so now we're gonna do the 8 steps of hypothesis testing. Step 1, we identify the claim. Step 2, we rewrite the claim in a math notation. And step 3, I'm gonna write this: P equals 0.5. Remember, your HO is always equal, okay? And your HA, or alternative hypothesis, is just this one. Is P greater than 0.5. And since this is a greater than, and we know it's going to be a one-tail test and it's a right-tail test. All right, now my next step, step four, choose the significance level. I don't really know. In this case, sometimes they say that, sometimes they don't. If they don't, then we just use 0.05. And in this case, did they say that? It seems like the question didn't mention. If they don't mention that, then we just use alpha is 0.05. It's by default. Okay. And what is my next step? I need to identify the test statistic. All right, now, do you remember that I asked you to print out the review sheets that I have with you? And here is part of that. And I hope that you can see. Here's a proportion, and this is what we're going to do today, and this is later. So if you want to do something about a proportion, if you want to do the hypothesis testing, you're going to use the normal Z and the requirements here and the test statistic. Did you see the formula here? Okay, and also I give you the test statistic formula, so let's do that. So my Z will be P hat, which is 0.52 minus P is 0.5 divided by the square root of 0.5 times 1 minus 0.5, Q, right? 1 minus 0.5 is also 0.5 divided by the n, little n, that's the sample size. So it's 926. Okay, so I use my little calculator. I did that, and I get the answer is 1.22. So I have my test statistic, 1.22. All right, now next. Okay, be very careful. Okay, so next what I'm going to do is I'm going to draw the Z-curve. I think you're already very good at this. Here's the Z-curve, okay? And I find my test statistic 1.22, that is a Z-score. So here I put 1.22. All right, now because this is a right tail test, so I'm going to shade the right tail here to the right of 1.22. And guess what is this? The area of the shaded area? That is my p-value. Okay, so for 1.22, to the right of 1.22 is the same as the area to the left of negative 1.22. So I just use the negative 1.22. I get a 0.1112. That's equals 0.1112. The next digit is a 3. So either way, you put that here. Okay. So you can put either 0.11123 or 0.1112. Depends on the table you use. At least, usually the z table give you at least 4 decimal places. Okay, so you have the p-value, right? Are you going to compare the p-value with alpha? Because the p-value 0.11 and alpha is 0.05, so p-value is greater than 0.05. If you have a small p, you reject HO. If you have a greater p, then you fail to reject HO. Fail to reject H. Oh, that's my step 7. Okay. And do you remember that I mentioned there's another way to do it? The other way to do it, alternative way, is to draw the z curve. Okay, 0. And then instead of finding from the test statistic to find the p-value, I use alpha, which is 0.05, and here is a z. I find this a critical value, and this critical value is the critical value is 1.645. 0.645. If you don't know how to find this number, you might need to go back to early chapters. Okay, so here is alpha, here's 1.645, and this shaded tail, that's my rejection region. Now, where is 1.22? Where is the z equals 1.22, which is here, right? Because here's 1.6. So this point, that's my 1.22. It's not in the rejection region. For the test statistic greater than 1.645, that falls in the rejection region, but those are the white area, so it's not. Therefore, you also get the conclusion, fail to reject H. Oh, okay. Until this step, you get most of your things done, but not actually finished yet, because you have to answer the actual question. So you have to translate your finding, or you have to translate your conclusion into English. Now we look at this. Okay, there is a flow chart. We're going to start. Now, does the original claim contain the condition? Here should be off. I don't know why it says or. Should be off equality. What's the original claim? If you remember, they said, oh, most of the internet user, they choose the two-factor authentication. So that was the original claim. The original claim does not contain 0. So in this case, does the original claim contain the condition of equality? The answer is no. Okay, then you would go down here. Do you reject HO? We fail to reject HO, right? You cannot, so you go here. You fail to reject HO. Now I want you to see very clearly what it says here. They said, there is not a sufficient evidence to support the claim that, and then you just copy the original claim. So your answer here should be, there is. So in the quiz or in the homework, they usually ask you to write you have to write your conclusion in English like this. Okay. So there is not sufficient evidence to support the claim that, what is the claim? Do you remember? The claim is that most internet users utilize two-factor authentication to protect their online data. Okay, so until this step, your job is done. Okay, so this way you can either use this method or you use this method, which means you either use your test statistic to find the p-value and then compare the p-value with alpha, or you go from an alpha to find the critical value and then you're going to find whether your test statistic is in the rejection region or not. You get the same, you should have exactly the same conclusion. Of course, if your z is 1.22, which is to the left of that, did you see that? From this point to the right, that area is greater than 0.05, right? So that's why these two methods, they're equivalent to each other. And then your answer is complete after you do this, after you answer the question in words. Okay? So that is that's this question, and that's this example. All right, now we're going to work on the second example. Example 2. A study of sleepwalking was described in Neurology magazine, and it included information that 29.2% of 19,136 American adults have sleepwalked. We have the sample size. This sample size is huge. It's 19136, and my p hat, the sample proportion, it's 0.292. Okay, so that's a research. Now, would a reporter be justified in stating that fewer than 30% of adults have sleepwalked? So the claim is p is less than 30%, or p is less than 0.3, right? So that's a claim, and the claim is the percentage of, or the proportion, or 30% less than 30% of American adults have sleepwalked. All right, and then we're going to use alpha 0.05. That's the question. So far we have pretty much all the information. So we already find the claim and we translate that into the math notation. So this is the less than. The original claim says less than, so that should go to HA. That was P is less than 0.3. Okay, and HO, remember HO always equal. So far so good. So we get HO and H1, or HA, the null hypothesis, the alternative hypothesis. And then we have the significance level 0.05. So again, this is about proportion, and then we test everything. So it's a binomial, blah, blah, blah. But however, the next step should be, yes, for this many people, 30% have sleepwalked, the other 70% have not, and you do the research for each people you include there, so either they have or they haven't. Okay, so anyway, test statistic, let me just write the formula here. P hat minus P divided by PQ over root N, and in this case our P hat, it's 0.292 minus 0.3. P is the one in the null hypothesis. So here is also, it's 0.3 times 0.7 over 19136. Okay, because I noticed some of you, when you do the calculation, when you use the calculator, you like to write the middle answer, middle result somewhere, but in that case, you have some rounding error in the middle, so your final answer's rounding error is going to be pretty big. So if possible, I prefer you to just find the as accurate as possible, okay? So in this case, I use my calculator, I get a negative 2.41. You can pause here and use your calculator to see if you get exactly the same thing as I do. All right, so for negative 2.41, I'm going to draw the z-curve. It's z. Here's a 0. And my test statistic is negative 2.41. And this is less than, so that's a left tail test. It's a one-tailed test, it's a left tail. Again, I'm going to use my 2.41, negative 2.41 So I get a 0.0798. So this p-value equals 0.0798. Okay, so what you're going to do, you're going to compare this p-value with alpha. If p-value is small, you reject HO. If a p-value is greater than alpha, you fail to reject HO. So small p, you're going to reject. But this p-value is greater than alpha. When it's greater than alpha, we fail to reject HO. Okay, now let me use another method. Again, I'm going to draw the z curve. Okay, here's a 0, here's a z. And I'm going to use alpha as the tail area and the left tail. You see what I'm doing? Alpha and left tail. So I go here. So that is the alpha equals 0.05. That's the area. And then I get a negative 1.645. Okay, so here's the rejection region, and here's not. What do we have? We have a negative 2, 4. Wait a second. I think I might have 0.0. Sorry, 0.0. There another 0. So this is less than. I'm sorry, because so your answer will be reject HO. See, I missed one tiny little 0, and it caused me so much trouble. Okay, so negative 2.41 is here. So at this point, that's negative 2.41, and that is in the rejection region. So you're going to reject HO. All right. Now you might ask, well, which method you want me to use? Either one, okay? Either one you want to use, but you should have exactly the same conclusion. You should have exactly the same conclusion. Now, once you have this reject HO, do you remember what was the claim? The claim is less than 30%, right? So does the original claim contain the condition of equality? No. Do you reject HO? Yes. Okay, so you go down here and say, there is sufficient evidence to support the claim that. So you're going to say, there is sufficient evidence to support the claim that, and the original claim says fewer than, right? Fewer than 30% of adults have sleepwalked. Okay, so that's your answer. Your answer is to support the claim. Say, yes, it is less than 30%. Even see the sample proportion is 29.2. It's just a slightly less than 30%. However, because the sample size is huge, so that is very significant, less than 30%. That's what we want to see. Okay, so I think till this moment that you already know how to do the hypothesis testing, and there are 8 steps, right? Find the claim, rewrite the claim as a math notation, and write HO and H1 or HA. Now an alternative hypothesis. Remember, HO always equal and HA could be greater than, less than. Those are one-tailed test. And not equal to, that is a two-tailed test. For two-tailed test, if you happen to have a two-tailed test, then, for example, if I have a two-tailed test with alpha is 0.05, then whatever, let's say just you get the example, z is 1.22, for example. I just give one example, 1.22. This is not your p-value. You have to add this to be this, add this, that's your p-value. So whatever you find on the table, you have to double it to get the p-value. And then very equivalently, that when you calculate the critical value, you're going to need half of alpha in order to get the critical value. Okay, so one positive, one negative, and the tail part is the rejection region, and inside you fail to reject HO. All right, so that is just the a two-tailed test. You have to really double the area, or if you use this method, you have to half of the alpha to put that on each side. But all the other steps are exactly the same. So I think right now you're okay to test a claim about a proportion.